Hi, everyone, and welcome to this session for World Rainforest Day on Innovating Tech for Conservation, hosted by XPRIZE. My name is Kat, and I'm the Program Activation Specialist for Climate and Conservation at XPRIZE. So I support communications for XPRIZE Rainforest. It's a 5-year competition to innovate the autonomous technologies needed for biodiversity assessment and ecosystem conservation. We'll learn a little more about the solutions being developed for that prize in this session, along with many more working and prototyping conservation tech solutions from our 4 incredible panelists who have firsthand experience in this field. So let's jump right in and meet those panelists.
All right. Hi, everyone. Thanks for joining us on World Rainforest Day. My name is Shah Selby. I am a conservation technologist. I came from the world of engineering, so I spent the first decade of my career working on satellites, and then learned about the challenges we were facing broadly in conservation across the world, and started doing research in the area of this intersection between technology and conservation. That was around 15 years ago now, when I first started doing that. I've since started a couple of nonprofits, the first being Conservify, and kind of the focus around Conservify was, even though it's a nonprofit, can we design it as a kind of a tech development lab, something similar that you would see in places like Silicon Valley, full of all this prototyping equipment, with the one caveat being that every single thing we work on is and will be completely open source. So once we learn how to design and code these things, we put that information out for anyone to replicate. And the second thing is we only work on wildlife conservation, environmental protection sort of projects. And the second nonprofit I started is called FieldKit. If you're interested, you could go to fieldkit.org and learn more about it. But that's really kind of looking at how do we change the fundamental issues that we see in environmental monitoring. So that's things like, the high cost of sensors, these complex and really hard to use systems, how a lot of the stuff out there is incompatible and proprietary. And so our thoughts were like, how do we redesign this from the ground up, using a lot of like the principles from UI and UX, user experience sort of stuff that you see with smartphones, and bring that into understanding how our environment is changing, water quality, air quality, weather systems, things like that. And so that's kind of what we're focused on there. I'm also an explorer with the National Geographic Society, and I was a fellow there for 3 years leading up to the pandemic, helping them think through what does conservation technology mean, and the work that Nat Geo does as well. And this background behind me that you see here is actually one of our field sites in Cameroon, where we're working with the Congo Basin Institute to deploy a radio network throughout the rainforest that's going to allow you to bring back data from any sort of sensor or other tool that you're doing there. So we've already put up some of it, and we're returning later on this year to finish it up. That's going to be completely open. Anyone can use it. Local scientists, scientists from all over the world can come in and try and understand what's happening in the Congo Basin and bring that data back live for anyone to see on the internet. So that's my intro. I think I pass it on to Kev next to talk a little bit about his background.
Yeah, thanks, Shah. Yeah, my name is Kev Marriott. I'm the tech lead for XPRIZE Rainforest. I'm responsible for the technical operations of the competition as well as its execution. The XPRIZE Rainforest is a $10 million 5-year competition to enhance our understanding of the rainforest ecosystem. Prior to joining XPRIZE, I worked with in wildlife conservation all throughout Africa, mainly dealing in technical capability development, so radio systems, technical surveillance systems, trackers, camera systems, that kind of thing. And I really kind of got my experience and forged everything that I kind of put into wildlife conservation through serving in the military for 14 years, and 8 years of that was with special operations, doing the same kind of work really with radio systems in a tactical environment and technical surveillance systems. So I kind of come from a military background, and then I transitioned quickly after leaving the military to work within wildlife conservation, and I started studying, and just recently finished my master's degree in wildlife biology and conservation. So I kind of blend the two kind of backgrounds really with conservation and technical as well. So kind of working as a technical conservationist, technologist, all in one really. So yeah, that's me, and I'll pass over to Sarah.
Thanks, Kev. So I'm a researcher at the intersection of computer vision, AI, and biodiversity monitoring and environmental monitoring. I just finished my PhD from Caltech in computer vision about 3 weeks ago, and I'll be starting up an academic lab at the intersection of computing and the environment, probably fall 2023. And a lot of the work that I've done has been really focused around, not only how do you train accurate machine learning models that are able to monitor biodiversity, recognize species, recognize individual animals, recognize environmental covariates from different types of data, things like images or audio or sonar or even, GPS tracks. But also, beyond just training these models, how do we think about deploying them? What makes a machine learning model robust and usable and actually useful for conservation technology? When can things be used off the shelf? How do you figure out, good systems for quality control over time? Because we know machine learning models tend to struggle with things that they haven't seen before. So how do you handle anomalies? How do you handle rare species or endangered species? And how do you make models adapt really efficiently to new parts of the world and new species that maybe they haven't seen? I've been trying to actually work on not just training the models, but actually deploying them and working directly with a lot of stakeholders. So I work with Wildlife Insights on their AI team. I have for about 3 years, trying to figure out how we scale up species identification and camera trap images. I was one of the initial builders of the Microsoft Mega Detector, which is now actually then incorporated within Wildlife Insights. But last year we processed 100 million camera trap images through that model from 60 different NGOs worldwide. And lately I've been doing a lot of work, field work actually. I got back from Kenya last week with the Mara Elephant Project and Impala Research Center, looking at how do we actually bring these tools and build these systems that combine the best of AI with the best of human expertise to get really usable monitoring for biodiversity. Eric, I think that's you.
Yeah, so, well, first of all, Sarah, congratulations on your PhD.
Thank you.
Yeah, it's one form of torture that it's nice to have behind you. So, hi everybody, I'm Eric Dinnerstein. I've been a wildlife biologist and conservation biologist since about 1975, when I went over to the Kingdom of Nepal and plucked out of undergrad with the assignment of censusing the tiger population in lowland Nepal in a newly created tiger reserve, which I didn't have a clue how to do, and we didn't have any technologies at the time. From there, I developed a strong interest in the tropics, and in graduate school, ended up doing my PhD in Costa Rica and Panama, studying tropical fruit bats and working on mapping rainforests on Barocaro Island the first time it was done. And then post that, I joined the Smithsonian for 5 years and went back to Nepal to lead a research project on studying tigers and rhinos in the field using technology. And then after that, spent 25 years as the chief scientist of World Wildlife Fund, which took me to lots of rainforests, spectacular ones from New Guinea and New Caledonia to Peru and Panama and Hawaii and everywhere, and had a great appreciation for rainforest conservation. I left WWF about 8 years ago to create a new program called Biodiversity and Wildlife Solutions at Resolve, a minnow of an NGO compared to some of the others that swim in the ocean, but very focused on bringing new technologies to bear. Much of what Shah has said, and Kevin and Sarah, to find ways to make the most advanced technology really affordable and to really scale it. And so I'll be talking about that as well in the next hour, of the innovations that we've created that from my early days of trying to measure tiger footprints in the sand with rulers and sketch paper to state-of-the-art AI cameras with embedded AI in the cameras that can detect tigers and send images back in 30 seconds to the end user. So that's my intro. I was asked to start this out, and I'll go back to my early days in tropical biology, which probably a number of people listening to this call are familiar with. The Organization for Tropical Studies, which has probably trained more tropical biologists than any other program based in Costa Rica, now in many countries. And one of the things that they like to do to get people to become more aware of what's in the rainforest and how does it work is you go out with your field notebook and a pair of binoculars and hopefully a keen mind. You had to have too many beers the night before. And your goal was to write down 20 questions. And often those questions should begin with why, or they could be as how many or whatever, but it's like those questions should reflect how you try to get to a deeper understanding of the rainforest and uncover its mysteries of how it all fits together. And that was the way that biology worked for so long. Tropical biology is you just went out with a notebook and you tried to come up with an original idea. I remember listening to a lecture during my OTS course, Dan Jansen, probably the most preeminent tropical biologist in the world. And I was sitting next to my friend, and my friend whispered to me, said, Eric, our goal is to try to come up with like one original idea in our lifetime. And like this guy comes up with one like every week. And that's what you need, is that great keen mind, that science, that innovation. And then from that innovation, then the technology comes in of like, okay, how do we do this? How do we do it better? How do we do it faster? How do we do it over a wider area? What's so exciting about what we're going to talk about today is we now have all these tools at our disposal that we didn't have 50 years ago of how we can monitor and understand rainforests in a much deeper way in real time, in many places where those biologists with their field notebooks, if you multiplied them 500,000 times, that's what we're trying to achieve with the technology. So we're entering this new frontier of understanding tropical forests. Our big challenge is, can we conserve it before it's too late? Because this is a very time-sensitive problem that we're addressing. I'll stop there and hand it over to the next person.
Yeah, thanks, Eric. I think that's a really great look at how things are, and I think this whole intersection of technology and conservation, a lot of us call it conservation technology, is just in such a unique space right now. Just because the ability for us to think of an idea, come up with a solution around it, get circuit boards made, or write some software around it, and get that stuff out in the field and testing. It's just the speed at which we could do that is unlike any time in history, right? And that's kind of the real exciting thing about where we sit right now. I think traditionally what I've seen in terms of how people bring technology into the field, a lot of times it's through a couple different ways, right? Maybe that technology is something that's used in other areas, so in the military or in agriculture, and with just a few small tweaks, we can use that. We can bring that over to help in field science and conservation work. But really, what I find is really exciting now is our ability to start from scratch and design these technologies to be used with like the conservationist as that core user. How do we create something that is easy for them to understand, that makes sense culturally in the kind of region that it's being used, and feels like you're not putting a Band-Aid on something, you're actually bringing something to the field that was designed explicitly for that. And the cool thing about that approach is it also falls back onto kind of the more traditional ecology and field science sort of studies as well, where a lot of those tools were created in a university or by some small firm, and they're not really optimized for that sort of thing. But once like things become cheap and easy, then folks look at like, one example would be in acoustic monitoring, right? There's these big expensive acoustic monitors that a lot of folks use to listen to soundscapes in the environment. And then, you have a small tool like AudioMoth that comes out, and that really changes the way that people think about how they're doing that research. Because, when for the price of one of these things, you can buy 150 of something else, then that changes the types of questions you can ask, which is exactly what you're just talking about, Eric.
Yeah, and I like the way that you mentioned about the bringing in existing solutions, especially from the military. Like my background, that's how I got involved in conservation. Was I was supplying military-esque capability to anti-terrorism organizations around East Africa and mainly Somalia, and the anti-poaching operations and the law enforcement on in protected areas. They needed the same capabilities, but they it's almost as if there's a real need for military style surveillance systems, but the budget isn't there, and that's always the struggle within conservation. I feel is that we're trying to deliver a similar kind of surveillance systems, especially within the law enforcement side, but with a conservation budget.
Yeah, I think actually one of the really interesting things from the perspective of like, what are we actually trying to ask and how do we answer these questions is, I think there's a lot of potential given the amount of data that we're able to collect. Shah talked about, okay, you can place 100 AudioMoths. But I think that one of the things that's then very challenging when it comes to this is people who get excited about the technology, go put out 100 AudioMoths, get terabytes and terabytes of data back, and then don't know what to do with it. And the actual human power that's needed to go through and process and extract the scientific insight from that data is huge. We are seeing really great advances on the AI side when it comes to helping to go through and process a lot of that data. But unfortunately, at this point, it's still to really be able to use machine learning effectively, to be able to get stuff that works well for your data. Usually it means you still need to have a data scientist or an AI expert in-house. There are very few examples, and Megadetector is one of them, where for most users, that model does tend to work pretty well for their camera trap data. But it comes at a cost, right? In order to build a model that would generalize, that would work off the shelf, we had to step back from our original goal, which was identifying species, and go back to just detecting animals, humans, and vehicles. And so that means you still need humans in the loop. Now, I've talked to a lot of different stakeholders using that model. It means that they're able to reduce their processing time from 5 years to a few months. They're now able to filter through that data, but it's still this interaction. It's still an interaction between machine learning results and humans, and there still is this verification and correction step. And actually, this is something, Eric, you mentioned that you have your cameras that are detecting tigers on the edge, and I think that's amazing. And also, it's something that detecting tigers is a very specific and well-constrained problem, and one that actually I think state-of-the-art machine learning is kind of ready to tackle with the right training data. So, I could see intuitively how that would be a pretty robust and pretty reliable model, but particularly when you're talking about tiger populations, where there's, it's a very at-risk species and also one that's very politically charged. Mistakes can be significant. And so I'm curious, Eric, like, for when you have these edge-based cameras where you're processing, detecting tigers in real time and sending those results, how do you think about quality control and risk when it comes to the data that's coming in?
Sure. Well, let me just respond quickly to some of Kev's great points too. And early on is your point, Sarah, about the terabytes of data being generated is the way I look. We cut through that is and avoid what we used to call in field biology as fishing expeditions. Is you start with a really powerful question, like what's most important, like what's most useful. So in this case, like how many tigers out there? I can't tell you how many heads of wildlife departments in Asia have asked that question. And that's what all the newspaper reporters want to know. And that's what the donors want to know, because has our intervention made a difference? So it's often that the hardest number to come up with is how many are there, but that's what everybody wants to know. It relates to what Kev has said, his military background, because so much of what we're doing, I mean, the military has all of this, right? Basically, and Kev would probably attest that it's just that there's lots of zeros attached to if you even had access to get it, you would pay a lot for it. And so and Shah's made that point, is we've got to figure out how to move this vital technology into the hands of citizen scientists, academic scientists, so that this can be useful so we can save rainforests and wildlife before it's too late. I think where a lot of this comes down to is a very basic question is, do the data that we collect, does it need to be transmitted in real time, or it can just be collected, occasionally or annually or whatever it is? Unfortunately for biodiversity, it's not like CO2. Like a single sensor on a volcano in Hawaii, because CO2 mixes so well, tells us what we need to know about CO2 levels in the atmosphere every year. That's not going, even as rich as the biodiversity of Hawaii is, that's not going to work for us for biodiversity. It's far too complex. And so that's our problem. But then if we disaggregate, what do we need to know in real time and what do we need to know once a month, once a year? As to Sarah's point about moving to identifying species, getting that information, like tigers, it really is time sensitive. We need to know where they are. They could be killing livestock and involved in human wildlife conflict. We want to know if a corridor we've created for tigers is actually being used by subadult male tigers that in their biology, they have to disperse to another area. Or what's the status of the population? Like in 2010, when we created the Global Tiger Initiative, the goal was T times 2, to double the tiger population in 12 years. 2010 was the year of the tiger. 2022 is this year is the year of the tiger. And I'm happy to say in about 5 of the 13 range states, we have doubled the number of tigers. And we've documented that by using camera trap technology. But as Sarah said, all of that data was collected. It had to be, someone had to go get the cameras, pull out the SD cards the old-fashioned way, and then go through them frame by frame and look, do we have a tiger? And then, gosh, is tiger A the same as tiger B? Now that's all changed because we have this, which is our new camera, TrailGuard AI. And in here is a computer chip from Intel, the Movidius Myriad 2 chip that runs AI on the edge. And we can just change the models, whether we want to detect tigers or other species, just by changing the SD card. Sarah, this will be new to you, as we've figured out how to move your great megadetector program to the edge. So we can now do animals, vehicles, people, or just animals by essentially changing the probability threshold, which you can talk about, to a much lower level. So you're basically getting all 4-legged creatures that walk in front of the camera at the time, trigger it, and then through a communication system we can talk about later, send that to headquarters, to the Tiger Authority in under 30 seconds, where you have cellular connectivity, and where you don't, we have a different system. So this is the revolution we're stepping into, and everybody has a big role to play. And like Sarah is saying, we couldn't have done this without working with a company, Savidia, that is one of the leaders in creating AI algorithms from synthetic data. But yeah, so it's a really exciting time to be a biologist and a technology person.
Yeah, I think that's a great example is your camera trap, just because it shows the potential that we have in designing these solutions specifically for the task at hand, because, the way they did it before was they bought a bunch of camera traps and all that data sat on SD cards, and then all those SD cards had to be manually collected, right? We worked on a project in the Republic of Congo around gorilla monitoring, and basically the team out there spent 100% of their time changing batteries and SD cards and camera traps. That's all they did, So when it came to the data came back and just sat on hard drives somewhere. So, it's really amazing to be able to create these tools very specifically to try and answer these sorts of questions. And I think that's something that we could do now quite easily. We started talking about challenges, so I'm really interested to hear what other challenges maybe the rest of you see in this space. around technology. One thing that I've seen over the years is there tends to be like this, excitement curve that comes up around a technology, and a lot of people want to implement that technology. And it's just, you can't fault the conservationists because they need better tools to do their job, right? And so they get very excited about these technologies, but sometimes, in this space, we didn't put enough thought into it before we take a piece of tech out into the field, if that's actually answering the question that we want to answer, or if the data that's coming out of that tech is going to actually help to solve the problem that we're working to solve there. I've worked in this space for a long time, but drones are a perfect example of that, right? Drones were thought to be the silver bullet for everything. And there's plenty of field programs that went out, bought a drone, used it, and found nothing of consequence to come out of the use of that drone. Whereas like maybe if like people would have stepped back and thought about this tool, what's the monitoring program look like? How do we understand what the limitations are to that technology and make sure that we're, not over promising and undelivering, and all this sort of stuff is really important to think about before you even take that first piece of tech out into the wild.
Yeah, I think that this is huge, especially considering that we all know that, conservation is not an area with unlimited resources, far from it, right? And so if someone's going out and hyping a new technology and people buy in and there's this excitement curve, and then they invest a lot of resources that really are hard won, and those resources are coming out of then other programs, and then the technology is a failure, it's not just like a hype bubble bursting, it's actually, actively and negatively impacting conservation efforts. And so I think that that's our responsibility as technologists and as conservationists, to stop overpromising, right? And be very, very careful about the tests that we undertake. And I think that can be hard, especially given I think one of the things I've kind of come across as I've worked with different conservation organizations is with the ways that funding happens in conservation, being able to talk about wow, we're using this amazing technology can bring in funding for organizations. It can be used to fundraise against. But then I think, that has consequences as well, right? It's something I've been thinking about a lot, and especially, when I start coming in, building out the sustainability plans and the relationships I have with stakeholders, when we're working on bringing a technology to the field to do beta testing, being very, very clear about, where the responsibility to maintain the system lies, and who's going to be paying for it, and how we're going to pay for it, and, if it doesn't work because it's research and it might not work, what does that mean? I think all of those things are really important and definitely can be very challenging to navigate.
Yeah, and I think some of that comes down to, developing technology as a nonprofit. There's no, you've got to try and make people realize the impact that it's going to have by showcasing the technology maybe in its development stages, when it's not quite ready to be deployed. But you have to show that it's going to work, and people get excited by that. And it's just kind of managing the expectations that this technology and the algorithms and things take a long time to develop. Just trying to manage those expectations of the biologists and protected area managers that really have an urgent operational requirement for it, and they want it now. And it's difficult. And I think that comes down to just purely the our mechanism of fundraising for people to fund the development of these things as a nonprofit.
Yeah, I'll pick up on that. Is about 10 years ago, I'll keep the names out of this, but I was involved in a major project funded by a big technology company to a conservation NGO. And relating to what Shah said, you could pretty much define the project as the answer is a drone. What's the question? And it was trying to shoehorn a technology that might not have been appropriate for the use case or for what the needs were, but that was what was decided upon by people who weren't the technologists or the biologists. It was decided at a PR level, and it broke my heart to see $5 million wasted in that way and not going to doing things that could have funded really important things. more important to what I think all the three other panelists are saying is I was at a conference about 8 years ago at Google, and a number of the major conservation groups were there and technologists. And they invited people from Google X to attend some of the talks. And this one guy who probably didn't have a conservation bone in his body, but was a great engineer and just listened to everything and came up with the most astute insight of the whole 3 days, which he said that, to me, everything you're trying to do, it all boils down to battery life and connectivity. You solve those two problems and almost everything else becomes possible. And I took that to heart when I heard that, because yes, that's the problem that we have. We have camera traps that people used to put out there that would, if they did transmit data, they would send everything and exhaust their batteries in 2 months, or they couldn't get the image out in the first place because they hadn't solved the connectivity problem. And this is where I think bringing in some of the advances and combining technologies can make a major difference. Let me give you one concrete example. That plant you have behind Sarah, I'm waiting for you to pick it up and throw it at me when I'm about to say this, but one of the most important reasons and advances of adding AI, embedded AI, so AI in the camera to our system, is saving on battery life. It's not the brilliance just of being able to detect a tiger from a leopard from a sloth bear in India, but that by filtering out all of the noise, so like everybody knows who's camera trapped, when you put your camera out there, you're going to get 75 to 95% of the images the camera takes are going to be of no value. And a big part of Mega Detector was filtering all that noise out. But what if you could do that on the edge so that you're saving all that battery life, such that this single 3.7 volt battery I have in my hand here just transmitted 2,758 transmissions over the cell network on a single charge, with probably another 2,000 false positives. I mean, you multiply that out, and if you set the cameras up right, that could be, if you're doing this for anti-poaching, this could be like 5 years of use in the field without changing batteries. So back to Shah's point of people going out to change batteries, hopefully, that's a thing of the past. And then to Sarah's point, the more accurate the algorithms, the higher we can raise the probability threshold, the more stuff we can flush out right at the edge and never transmit. And then on the connectivity side, by engaging with companies that are already doing this, but using our advantage as conservationists, we can get great discounts on the critical piece of all this, which is airtime costs. So all the technology we have, if you couldn't transmit the data in near real time at a low cost, then it's back to the drawing board, because you can't get the data out. So fortunately, there are companies like Inmarsat that make this incredible. This is a satellite modem. I call it, for those old enough to remember, this is the Hostess Twinkie size. We have one that's more like a Belgian waffle that's a little bit bigger. But you put this out there, as long as you, and Kev has used our system, as long as you have this to the right angle to the satellite that's 36,000 kilometers above the equator, and the right azimuth, like for me, I have to point mine to the Galapagos here in Washington, DC, you'll have 100% satellite connectivity, and you can send data very quickly to the satellite, to your system, to your headquarters, to your research lab, in under a couple of minutes. So that all makes, that gets back to this question of, we've got to solve the battery life and the connectivity issue, and a lot of different technologies impinge on making those solutions possible.
I really like that point, actually. I was just going to say, like, around with AI saving battery life, but I think this has been something, it comes back to that question I had about risk earlier. This has been something I've been thinking about a lot, which is basically machine learning models. We know that there's model drift. We know that over time, model accuracy on one data set might start to degrade. And one of the things that I've been thinking about is, how do we make decisions about when and what data to send, so that we can both try to capture, as many of the animals as we can. We're minimizing the number of false positives, but we also have some protocols in place that are sending data periodically as just quality control, just as a way to try to understand and have this verification over time as the real world changes. that our model is not, you know, deviating from reality and starting to detect fewer and fewer animals, for example. And I think that that's actually a really important research question we have to solve. Like, how do we do real-time consistent verification of AI on the edge?
Yeah, I just I wanted to add on that battery life and connectivity thing. The great benefit is that, you know, this problem is one that the entire technological industry is trying to solve, right? So so us as conservationists are benefiting off of the development that's going into that sort of work, but that is the thing that's the limiting factor on a lot of these sorts of deployments, particularly since you know, some of us work in some very remote parts of the world. I mean, the project that I talked about here, you know, we have to hike with everything on our back for 30 kilometers into the middle of the rainforest, and there's nothing around. And we're already in a pretty remote part of the country. And so this is what a lot of these you know, the solutions end up looking like. How do we create something that's going to be reliable? It's going to last for a long time. You know, a big part of it is, you know, if it fails, how can we make sure it fails in a way that's more graceful? So, you know, don't destroy all the data on the device. Don't fail in a catastrophic way that's going to mess up the ecosystem even further. You know, like there's a lot that goes into the design of these sort of systems. I think one of the things I'm particularly excited about with FieldKit is, like, we work a lot with indigenous scientists and folks in those communities. So, you know, conservation decades ago was really a lot of scientists from Western universities flying into high biodiversity areas, collecting a lot of data, and then going back to you know, the places where they came from. And the interaction with folks on the ground just wasn't quite there in the way that I think it's getting there now. And so, you know, a lot of the stuff when we're thinking about what you know, how can we build a low cost sensor that can help X, Y, and Z, like, we're working with those communities and deploying them. I'm actually going in a week and a half to the Amazon in Peru to work with a lot of our partners down there that are out there collecting water quality data and water level data, and trying to understand how their little corner of the Amazon is changing over time. And I think that has potential both on the hardware side, even though, you know, now it's a very hard time to build hardware because of the supply chains, but also on the data side. Like, how do we make sure that the data comes out is accessible to these communities, easy to understand and explore? And, you know, there's a lot of really cool opportunities there.
I could just maybe just jump ahead here just to say, we published two papers in the last few years in Science Advances, one called The Global Deal for Nature and the other Global Safety Net, that maps out where 50% of the Earth needs to be conserved to reverse biodiversity loss and stabilize the climate. And one of the most important findings of the paper was that of the 50% that we need to protect to achieve those goals and avoid these existential threats to humanity, that indigenous areas that are occupied or maintained or indigenous groups have title to, were about 35% of the global safety net. In other words, the single most important thing we could do to protect life on Earth is to empower and finance indigenous peoples to be able to better protect their homelands. We've just been involved in our first project to protect an indigenous reserve in Brazil using our technology, and really even beyond just helping to monitor, like, how many jaguars are there out there or tapirs. It's everything in the Amazon moves by boat, so the boats are the roads of that system. And there are a lot of intruders in indigenous reserves that shouldn't be there, and they're doing things that they shouldn't be doing, whether it's gold mining illegally or hunting or cutting down trees or whatever the activity. And the indigenous peoples there have no early warning system of how to do that. So now we have River Guard that can detect boats coming up rivers, which you could add an acoustic element to as well to pick up the sound of the motors, so that they can have an early warning of intruders in their reserves and give them the heads up. So that's also vitally important for protecting nature in the wild and supporting indigenous people at the same time. And other indigenous First Nations groups have approached us as well in Canada, asking for similar technology so they can monitor incursions into their homelands.
Yeah, I mean, I just like to say as well, you know, the challenges of working in the rainforest environment, and you know, that how that plays on the integrity of the equipment and the solution, to withstand, being used within a rainforest, in an area. It's probably the most challenging and demanding environment, on land anyway, especially for communications and getting that communications link. You can choose a more difficult environment really than a rainforest. So it's one of the things that during the Rainforest XPRIZE competition is one of the biggest challenges really is getting that connectivity out, and also making sure that the systems are going to last and work. And I know, Eric, you've done a fair amount of work in making sure that your systems will withstand being used in those environments. So it'd be good to kind of, if you can elaborate a little bit on those as well, that'd be great.
Sure, maybe I'll let somebody else people talk to, since I just jumped the line here. Sarah,
I know Shah's done some work on it.
I mean, it's a very challenging environment to work in. Some of these places just get almost unbelievable amounts of rainfall. It's a rainforest, and so some of the stuff that we've really struggled with is just kind of the topography of those regions. A lot of them are very hilly, and so communications gets quite difficult. Also, we like to do things solar powered just because that extends the life on them, and solar panels are dirt cheap. However, that doesn't work super well when you're underneath the canopy. So there's a lot of consideration that has to go into those sort of things as well. And particularly if you're looking at things like, like water quality and stuff in those regions, then you have to deal with biofouling. And, it's just the list of things that you have to worry about grows more and more. We've had a lot of stuff eaten by insects, and so it's quite a complicated thing. It's a tough problem to solve for. But once you get something that's working quite good, it's pretty rewarding. It's a lot easier than putting it, out in my backyard in Los Angeles or something like that, right?
Yeah, and I mean, even hilly can help sometimes. Flat is also a problem. If it's too flat, you've got no elevation, so there's nowhere, for kind of getting a line of sight radio connectivity and things like that. There's nothing.
Which is, I mean, that's a great point. I mean, this region of Cameroon in this picture behind me, part of the reason why we picked it for this sort of technology that we're implementing is because they have these giant inselbergs that jet out of the rainforest that make these beautiful radio towers, effective radio towers. If you put things at the top of that thing, then the view you have around it is quite phenomenal, right? And so that's I think that's a really great point. As much as you can use that environment to your advantage, like that is the way that you can make these things successful.
Yeah, I mean, rainforest, pretty much the only way you get in communications is up. Yeah, you trying to punch through all of that, foliage and trees and everything, especially when it's misty, and then you're just dealing with even more higher humidity. It's almost impossible. So with working radio communications in the rainforest, you're pretty much limited to just trying to punch straight up through the canopy, and then using all kinds of different techniques to try and get the radio signals, especially with HF, and using it to basically refract off the atmosphere and back down, almost like an umbrella type coverage. But we're firing it up straight out through the canopy. Trying to work line of sight on the forest floor is almost unworkable.
Which is why I think where this has to go are sat modems like this. This is about $350. It all depends on how valuable is that data to get out. You could have multiple sensors talk to the gateway that we've built, which is this little guy right here, that can transmit over cell, long-range radio, or satellite. It's the same as the transmitter end as the receiver. You just change the software. And Shah, we should talk about this later on. But this is now being manufactured. And to me, as long as we can get cheap airtime rates and cheap sat modems, you can be anywhere in a rainforest. I mean, so Kev, like where we were working with you in the DRC, where you've got the worst situation where you don't have inselbergs, but you just have hilly rainforest, how to get stuff out. I think this is really about the only way I've come up with, that can reliably transmit data when you need it.
One of the other things, so obviously, I think the data transmission is a universal challenge. one of the things that I think is super interesting also about the XPRIZE is, we've talked a lot about static sensors, static cameras, but I think there's a lot of power in the potential of these multimodal data collection systems. How do we think about, going beyond just a network of static sensors, but like actually active data collection in the environment through autonomous systems, I think is really exciting. And some of these other newer types of technology like eDNA, like metabarcoding, ways that we're trying to collect variable types of data. I don't think that images alone are going to give us the whole biodiversity picture. Audio alone won't give us the whole biodiversity picture. And so I'm really excited to see what comes out of the XPRIZE in terms of these like complicated systems of static and mobile sensors collecting all these different modalities of data.
I think that something that, if I was to give my vision of where this is going to go in the next couple of years, is building on what Sarah said, is the most important innovation that I see on the horizon is when we get spectrometers in space. So Greg Asner, who I consider the world's leading environmental scientist, is head of a NASA mission, Carbon Mapper, that's going to send up 2 spectrometers that basically every 18 days are going to give us a new vegetation map of the Earth that can distinguish oil palm plantations from intact rainforests, things that are really hard to do from satellite right now. And basically, I almost see this as global ecology before spectronomics and global ecology afterwards, because the data that we're going to have to ask these questions are going to be phenomenal. We'll have a map of the world's canopy every 18 days. Our challenge, everybody on this panel, is like, how do we figure out if that diversity is still there under the canopy that the spectrometers can't see? But if we can put the 2 of those together, that's the vision for how we monitor life on Earth going forward.
Yeah. I mean, that Greg Asner's work is going to be a game changer once it's put into orbit. It's going to be make a huge difference. One of the other things is kind of collaboration on producing these solutions. We all work for nonprofits, and that makes it a little bit easier for collaborating between ourselves and just trying to help everybody out. And I think that there's been a great shift over the last kind of 5 years that I've noticed, where people are tending to work together a lot more and not be as protective over the solutions and help each other out, because we're all trying to achieve the same thing, which is conserve what's left on in these protected areas. So yeah, I think it's collaboration's also pretty strong within the conservation technology industry, I suppose.
Yeah, I mean, I'll echo some of the stuff that was already spoken about. I think this Rainforest XPRIZE is going to be really a game changer in pushing some of these technologies forward. And then, like the stuff we're doing with FieldKit or TrailGuard, or a lot of the thought around making these sort of systems smaller, cheaper, more accessible, then you can get that ground truthing that can go with like the space-based stuff, and we can get a really interesting understanding of how these places are changing over time. Conservation in general, like we're not doing so good globally. We have small successes here and there, but I think with climate change we see the general trends, and the faster we can get these better tools out to people, I think the better we can understand how those changes are happening and potentially try and step in and make some mitigations or help to reduce some of the pressures on some of these ecosystems. And I think that's the key thing, right? Is like, how do we make sure that the work that we're doing contributes to this larger goal and this final outcome of making sure that the rainforests are there for our children and our children's children and everything into the future. So.
Well, we're all out of time, but I would like to thank our panelists so much for joining and teaching us so much about these new tech solutions that are coming up to help conserve biodiversity and rainforest ecosystems. I feel like I learned a lot, and I hope you did too. If you would like to learn more about XPRIZE and the XPRIZE Rainforest, please follow us on social media at XPRIZE, and you can find us at xprize.org. Thank you so much for joining, and happy World Rainforest Day.